Boa noite a todos. O meu nome é Renata. Hoje eu estou aqui representando o professor Carlos Greff Teixeira, então, da ProPesc. E eu queria rapidamente, para não tomar muito tempo da palestra, só fazer uma breve introdução. O Fórum de Interdisciplinariedade está entrando no seu 5º ano e ele foi criado para se conhecer o que é feito na PUC, também fora da PUC, para se ouvir a sociedade, para ouvir os problemas socialmente relevantes e para estimular esse tipo de abordagem interdisciplinar. Ele está dentro do Plano Estratégico 2011-2015, dentro do projeto Interação, que está sob a responsabilidade da ProPesc. Nós temos um site, que é o www.pucrs.br/Fórum Interdisciplinaridade, e um e-mail. Nesse e-mail vocês podem mandar sugestões, inclusive de temas para serem abordados, críticas, elogios. E todos os nossos encontros eles são gravados e o DVD depois fica disponível na Biblioteca Central. No momento ele está sendo transmitido online. E aqui eu mostro para vocês então alguns temas, eu não vou entrar em detalhes, mas alguns temas que já foram abordados. A gente pode ver que é uma temática bastante ampla. Os mais diversos assuntos já foram discutidos aqui. A gente também está nas redes sociais, então no Facebook, no Twitter e no YouTube também tem um canal onde são disponibilizados os vídeos, então se vocês quiserem tirar alguma dúvida depois, esses vídeos são disponibilizados no YouTube. Agora eu vou passar a palavra para a professora Renata Vieira, que vai vai apresentar o nosso convidado e depois vai coordenar a mesa.
Good afternoon. It's my great pleasure to invite Professor Peter Gärdendors for this talk here at the Interdisciplinary Forum. He has done very interdisciplinary work, and he has published many books. One of them is the subject of his talk today. It's a book which he defines as more popular science, because it is not so technical, so it has a more broad audience. And this book is being translated to Portuguese, and the university is publishing the Portuguese translation of the book. So he has this week visit also URGS. He has been worked with Sandro. Sandro has visited him in Lund, at Lund University, where he's from. Sandro is a PhD student and has done this year over there. So I invite him to talk a little bit about the bio of Professor Peter Gärdendors.
Thank you, Renata. Well, who is Professor Peter? He's professor of cognitive science at Lund University, where I went. Met some very nice people there. And he is also a member of the Academy of Sciences of Sweden. He's also a member of the prize committee of the Nobel Prize in Economics. And he has worked in many, many different areas, biology, starting philosophy, mathematics, computer science, cognition, and more recently in evolution, which I think is the theme of the talk today. So, Professor Peter, would you like to start?
Well, thank you for the introduction. When Linnaeus, the Swedish biologist, was categorizing all animals and plants in the world, he was using this system of having a family name and a species name. So he invented a family name Homo, and that had 2 species. Something that is now called a chimpanzee. He didn't know very much about it at the time, what the chimpanzee was, but that he called Homo troglodytes. And then we had the other species in this group was the man, the human being. So he gave it the name Homo sapiens, the wise Homo, the wise man. That was his name. Then some people didn't like that the chimpanzee was put in the same family as the humans. So later, the chimpanzee got its own family. It became pan-troglodytes. So there was only one Homo left, and that was Homo sapiens. But anyway, Linnaeus had this idea of thinking of us as the wise animal somehow. So my question is, first of all, in what sense are we the wise animal? And how did we become Homo sapiens, the wise animal? So if we take a simple picture here, we think that we have a different way of thinking about the world than other animals. We can reflect upon our own existence, we can ask the deep philosophical questions, and as this picture shows here, we have language in which we can formulate these questions, while other animals are thinking about more down-to-earth things. This is our picture of ourselves. And the question is, well, is it true? And how much difference are we from other animals? So if you compare us genetically to our closest relatives, the chimpanzees, we share 98.8% of our genes, quite a lot. The difference is not very big. We separated from what was to become the chimpanzees some 6 to 8 million years ago. And from an evolutionary point of view, that's not very long time. But we still think that has happened a lot of things during that period. We have, first of all, got language, we built up societies, we've got science, we've got literature, we've got art, we have a lot of things that we don't think we find in the other animals. So my question is, what has happened during this period since we separated from the chimpanzees? So this is what I call the evolution of thinking. I will not talk very much about the biology and so on. I will talk about what's happened in our heads and compare that to what's happened or what happens in the heads of some other animals. Okay, I will divide my talk into 3 parts. I will talk about what's happened to our cognition, our thinking. I will talk about what happened to our communication. I mean, that's not only just language, but in general. And these 2 parts are actually in my book that Renata has been so kind to translate into Portuguese. The 3rd part, levels of cooperation, is something I did after I wrote the book. So that's more new stuff, actually. And there isn't very much about that in the book. But my thesis is that there is a kind of co-evolution. We got better at thinking, and by getting better at thinking, we got better at communicating, and by being better at communicating, we got better at cooperating, and cooperation led to more thinking, and so on. So it's a kind of spiral between these 3 parts going up. So I want to talk a little bit about each of these 3 parts. So let's start with cognition. I want to talk about 2 main things that I think has happened in the human mind. One is our perception of time, our relation to the future and the past. That's one part. The other part is what is called, philosophers call theory of mind, what psychologists call intersubjectivity. That is our capacity to understand what others think and believe and feel and so on. I think that these are the 2 main components that has evolved more in humans than in other animals. We find traces of it in other animals, and I'll talk about that. So let's talk about, in general, we have a richer inner world than other animals. I mean, Daniel Dennett, the philosopher, says that we have 2 environments. The outer one where we live in, and then the inner one where we think about the world, so to speak. And what thinking means here, I will try to tell you a little bit more about. So in general, the human inner world has more components than the inner worlds of other animals. I'm not saying that other worlds don't have inner worlds, and I'll very soon explain why. So let's start about the time thing. And I will study our relation to time by looking at different forms of planning. I'm not talking so much about memories and so on, but we could do that as well. And I want to make a distinction between 2 types of planning. One is planning for the needs you have now. You are hungry and you want to find food. You are thirsty, you want to find something to drink. You're tired, you want to find a place to sleep, and so on. We have needs and we want to solve them. And lots of animals can plan for this. So here is one example of planning. Chimpanzees like to eat termites. Termites sometimes live in the ground, sometimes in termite hills. And when they find a termite that is a good place for them, I mean, it's not always possible to get the termites and so on, they walk away from the termite hill, go to a tree, break off a branch, peel off the leaves of the branch, and then they use the twig to probe into the termite hill, and then the termites attack the branch, and they pull it out and then lick off the termites. The important point here is that they are close to their goal. They want to eat the termites, and they like them very much. But they have to leave the termite hill to get a tool to bring this branch back again so they can perform this. And that means that they have to have, or the interpretation of the biologist is that they have some inner picture of this tool. They have some kind of mental representation of this tool, and they go away and prepare this. And this is not something that is very easy. Young chimpanzees can't do it. They look at their older and they try to do it, but they fail at the beginning. It takes some time to be able to prepare this twig that you get the termites from. But the important point here is that they have this picture of the tool before they create it. This is the planning phase. And they go away to create this tool, and then they come back and do the fishing for the termites. Here is, if I can get, now I would actually need to get to my computer. This is a movie from a German psychologist, Wolfgang Köhler, who in the 1910s had, let's see if I can get this running. There is the movie, and then I have to find my cursor. Okay, we're coming here. Just to get it running. He is in the Canary Islands with some chimpanzees, and he's placing a banana in the roof. This is look at how they stack the boxes. They're not very good at this. I mean, they don't know the statics here, but finally, okay, they're failing, and there is no really cooperation here. The others are interested, but they don't. But now, finally, this guy gets the banana, and there is a small piece left. So, yeah. Now there is a more difficult task coming up here, and that is, there is a banana hanging up in the top. You don't see it. But now the thing is to have a long stick. And look how agile they are. The stick was placed at the wrong place, so now it's moving the stick. And now it got the banana. Okay. So this is another incidence of planning. You notice that it moved. It tried to get the banana with the stick here. And then it failed. So it moved, not the stick, the pole. And it moved the pole here, and then it got the right. So it tried first, but it realized it was the wrong place, and then it got it. So this is another. Köhler wrote about this as the chimps getting an insight. He used this word insight when they put the boxes on top of each other or put this pole in the right place. But he also noticed that when the chimps are planning, they only plan for the needs that they have now. They only plan when there is a banana present, or when they are needing something, or when the termite hill is there. So this is what we call immediate planning. Then there is another type, that's the modern terminology is prospective planning. And that is planning not for the needs you have now, but for the needs you have for the future. So I may be very full now. I've had a very nice lunch. And I come home to my apartment, and I look in the refrigerator, or I had a nice dinner, say, and the refrigerator is empty. I don't need any food, no. But I realize that tomorrow morning I will be hungry again. And when I wake up, I don't want to go out and make the shopping. So I go out now in order to have food for tomorrow. And we all do that. I mean, we can plan for longer periods. I mean, I may be warm and cozy now in the summer, but I realize the winter is coming in a few months, so I build myself some kind of protection, a hut or a house, so I can be nice in the winter. I mean, I plan for my needs in the future. And I hope you see that this is cognitively more difficult, because if you're planning for current needs, you're hungry now, you don't have to imagine your hunger, you feel it. But if you're planning for the future, you have to imagine yourself being hungry. You have to imagine yourself being cold in the winter, and so on. So you have to have some plan for you have to think about your needs. You have to imagine your needs in the future. And that's cognitively much more difficult. And Köhler said that it's only humans who can plan for the future. The chimpanzees can plan, but they can't plan for the future. And this was a dogma for quite some time. But then, okay, I already said this. And I should also say this thing that our capacity for plan for the future leads us to a dilemma. If I had a very nice dinner, I may want to lie down on my sofa and just relax. I don't want to go out. But I have this dilemma. I realize that tomorrow I will be hungry. So I have to choose between my needs now and my needs for tomorrow. The other animals don't have this dilemma because they live much more in the now than we do. Or I can choose between smoking now or giving up smoking and being better in many years ahead of time. We have to choose between these things, and that's a human dilemma. But as I said, there was a dogma that, I should say that these two. We know that this capacity to block our current desires, what we want to do now, is dependent on the frontal lobes of the brain. That's where the so-called executive functions are located. And the human brain is much bigger than the chimpanzee brain. There are no new parts in it. There are some new functions related to language, but no new parts. The chimps have let's say that the human brain is about 3 times as big as a chimpanzee brain. But the frontal lobe is 6 times as big. So that's the part that's grown the most during the evolution. So the interpretation is that the frontal lobe is needed for this kind of planning for future needs. Okay, now we get over to the dogma. And it was a dogma that only humans can plan for future needs. But only a few years ago, the first paper was published in 2005 by a group from Leipzig University. They showed that some of the ape species could save a tool overnight and then use the tool to open a box that contained some reward, some fruit, the day after. So they knew that they could save the tool. But then when this was published, the psychologists were criticizing this experiment because they were saying that the chimps could have learned to associate the tool with the future reward. So this group, Malkoy and Cole, didn't check for the possibility of associative learning, as it's called in psychology. Then a former PhD student of mine, Matthias Oswald, he made a better variation of the experiment, and I'll tell you about that. These are chimps in a zoo in Sweden, and this is a box with juice, fruit juice, and the chimps like the fruit juice very much. And this is a plastic tube that they can use to suck out the fruit juice. So what happens is that they see this box with the fruit juice is in a special cage. And they see that Matthias is filling juice into this box. Then he leaves the box, goes out into the common cage where all the chimps is, and they are presented with a choice between some funny things that they can play with, and they are presented with this plastic tube. And they all know, I'm sorry, I forgot to say that, they know that they can use this plastic tube to suck out the juice. And all the chimps that were presented with this choice, they picked the plastic tube. They couldn't play with it, there was nothing to do. And they had to carry that around among the other chimps for a couple of hours before this room was opened. And then they could get access to the juice and drink it. So this part is just as in the Leipzig group. They saved the tools for future needs. We still haven't controlled for this associative learning. The second part in Matthias's experiment was that now they are given a choice. The box is loaded. They're given a choice between this tube, a few irrelevant things, and a grape. Chimps like grapes, but they like a box of juice more. So they could choose between taking the grape now or taking the plastic tube. So they could choose between having a small reward now or a bigger reward in the future. Almost all of the apes took the plastic tube. I mean, if you do this with children, I mean, give them one candy now and say that if you wait, you will get one more candy. Not every child will succeed in this. They will take many children will take only one candy. So that's not a problem. The important thing is that then, as I said, once they had taken this plastic thing, they were given the same offer once again, a grape or a plastic tube or something irrelevant. This time, and the chimps then had one plastic tube in their hand. This time, all the chimps took the grape. Do you see the point of this? That once they have the plastic tube, they don't need one more plastic tube in order to get the soup. Now they can take the extra reward of one grape. And this is showing that it's not associative learning. They understand, because if it was associative learning, they would take lots of plastic tubes. So that's that part. They abstain from smaller rewards now. I mean, that's the second part. And the third part of the experiment was that when this was done, they were presented. They saw that the box was loaded. They were presented with a tray that had 3 irrelevant things, and then it has a yellow plastic cable. In Sweden, this is used for electric cables. And they've never seen a thing like this before. They've never seen this plastic. It's yellow, it's stiff, and it's thicker than so it has visually totally different from the ordinary plastic tube they're using over here. And they were offered this choice again with 3 irrelevant things and this plastic tube. Everybody picked the plastic tube, the yellow one. And the interpretation is that they understand that we can use this to suck up the juice. And as soon as they got into the cage, they all put it on top of it. You see that now they have to have a much more complicated. They have to suck from above, so it's more difficult to get the juice. But they all understood that immediately. They put this yellow thing into the box, and they were able to suck. They had never seen this yellow thing before. So that's another piece of evidence showing that they don't. It's not associative learning. There was no learning in relation to this tool whatsoever. So there are a series of experiments showing that some of the great apes, I mean, chimps, gorillas, orangutans, can have some planning for the future. I mean, a few hours overnight and so on, and in certain situations. It's been tested on some birds as well, scrub jays and ravens. And they also have a bit of this capacity. We still don't know how far we can extend the capacity. So what it means is that we see some traces of planning for the future in the great apes, at least. But still, as humans, we are much better at it than the other animals. But these are quite new experiments, as you see. Okay. That's what I want to say about the apes. Now, if we look at the human history, the first tool we find are about 2.5 million years ago. They were found in East Africa, and they are very crude tools. I mean, a chimpanzee could make these tools, so it's not that difficult to make them. But archaeologists have been able to show that these tools were transported over large distances, over tens of kilometers, because they are found in areas where this material is not available. So 2.5 million years ago, humans were transporting their tools. I showed you how the chimps make a twig to fish termites. So chimps can make tools to solve problems, but they never transport them. They only use the tools, make the tools when they need them. But we as humans, we started thinking about that. I can use this stone when I come to this next place where we're sleeping tonight or whatever, or where we will be hunting tomorrow. I may need it. So I bring my tool along. And so that we have archaeological evidence that already 2.5 million years ago, humans were planning for the future, since they were carrying. And actually we have become Homo transportans. That's not a proper name, but anyway, I like this. We are carrying our future with us all the time. I mean, you all carry money and telephones and notebooks and tickets and whatever. I mean, and we carry water. I mean, that's one thing we don't see archaeological traces of. But I think that an important part of human evolution concerns our ability to carry water when we are traveling. There is no other animal that carries water. We are the only ones. So we have evolved a capacity for carrying the future with us. So we have much better planning for the future than other animals have, even though we find traces in them. Okay, that's what I wanted to say about the planning capacity. Now we get into subjectivity and what philosophers call theory of mind. And there was, again, another article from the Leipzig group. I mean, they are really the best in this area. They made a number of tests on 2-year-old children or chimpanzees and orangutan. Some of the tests had to do with our understanding of the physical worlds, how things fall and how they move and so on. And these were tests that could be given to all the 3 species, non-linguistic tests. You didn't use languages all. They had to solve problems. And as you see, on the physical domain, the humans and the chimps are solving about 70%, and the orangutan is slightly less, but I mean, it's within the error or margin here. But then some tests were on the social domain, understanding relations between individuals, and I forgot the details, but it doesn't matter. And as you see, here the humans are much better. Immediately when you get to social relations, where even a small child is better than an adult chimpanzee. So we have evolved some capacities for social reasonings that we don't find. So now I want to talk a little bit about how I analyze intersubjectivity, and that's actually part of the book. I break down this intersubjectivity into 5 different parts here. One is understanding the emotions of others. That's what we normally call empathy. Understanding the attention of others, and that's mainly following the gaze of somebody else. And then representing the desires of others, understanding what others like and don't. Representing the intentions of others, understanding what their goals are, what they're up to, so to speak. And then understanding what others believe and know. So I break down this capacity in these components, and I want to talk a little bit about each of them. Before that, I want to say something about compare animals with children here. Empathy develops very early in children, and we find it in all mammals and in some birds. Attention we find develops in children. I'll say more about that a bit later. Primates have it in some other species. I'll talk about it in a minute. Children develop understanding of the desires of others about 1.5 years old. Intentions of others about the same age. It's very little known about which animals understand the intentions. Very few experiments in this area. And understanding the beliefs of others develops between 3 and 4 years of age. I've ordered these capacities here since in this order because you can see that there's a progression in the age of the children. But you can also see that fewer and fewer species are capable of it. So there is an evolutionary aspect as well. So here we have all mammals and some birds. Here are some species. Here it's only primates, maybe not all of them. Here it's maybe only chimps. And down on this capacity, we've only found it in humans so far. So I think there is some good reason, both from a developmental point of view and from an evolutionary point of view. So let's talk about them, each of the capacities. Representing the emotions of others, that's empathy. We find evidence for that. I mean, animals are willing to abstain for a small reward in order not to hurt somebody else. There are simple experiments showing this. There is a speculation that the mirror neurons in our brain is used for this empathy. I don't know how strong that evidence is, but some people think it depends on that. Then we can also talk about a stronger form of empathy. That is, empathy means that when I see somebody's happy, I become happy myself. I mean, I react with the same emotion. And if you look at small children, I mean, they are very strong at this. If somebody starts laughing, then the other children start laughing. I mean, it's like an reaction of an epidemic of laughing. And if one child starts crying, the other children starts crying. There is immediate... but when we grow up, we learn to control our emotions. If somebody starts laughing out loud, I don't start laughing out loud, not always at least. And if somebody starts crying, I don't start crying. We can understand the feelings of others without reacting in the same way. And if you're working in a hospital or taking care of people, I mean, who are suffering, you don't want to be suffering yourself in the same way, because then you couldn't survive. I mean, you have to block your empathy. And this is called cognitive empathy. And there is hardly any evidence for that in other species. There is one exception I should talk about here, and that's the capacity to comfort somebody. If somebody's been hurt, then you can comfort them. And we see that in the great apes. I mean, if somebody has been bitten or hit, a friend comes and gives comfort. We find this comfort also in elephants. Elephants comfort each other with their trunk. We find the comfort in some of the birds, in the crow birds. They polish each other's beaks as a kind of comfort sign. And comfort is more advanced than empathy, because that means that I understand that you've been suffering, but I also understand that I can do something about it. I can help you to feel better by caressing you or something like that. So some species have this capacity as well. Okay, that's about all I want to say about empathy. Then we look at the attention. And if you put a child in front of his or her mother, and the mother turns her head, looking at something, then the child turns in that direction when they are 6 months old and look at what the mother is looking at. When they are 12, they can do this if she only moves her eyes from left to right and so on, not moving her head. When they are 6 months old, they can't do that. So there is a kind of better understanding. And I showed this picture in a lecture yesterday, but I show it today again. See the difference between the eyes of a chimpanzee and the eyes of a human? There are two main differences. One is the shape. The human eye is more almond shaped. It's longer in the horizontal direction. These are more rounded. And the sclera of the human eye is white. Of a chimpanzee, it's brown or reddish. These two features of the human eye makes it much easier for us to read the gaze of others. We can read with large precision. Where I can see where you're looking, and I can see with fairly large precision turn my own gaze to that direction. So somehow evolution has given us these tools for understanding where others are looking at. We have got these white sclera and the almond-shaped eyes. And there's a third step in the development in human children. If the mother starts looking at something that is behind the child, a 12-month-old child will not turn around. But the 18-month-old child has developed this understanding that the space is not all what I see. There are things behind me. I have this, it's called the allocentric representation of space. There is something behind me. And if my mother is looking there, this 18-month-old child will turn around and look at the same thing. So that's an extension. And if we look at animals, all the apes and monkeys, dogs, goats, dolphins, and ravens can also follow gazes. I don't know how the experiment with dolphins was made, but that doesn't matter. So we see that following the gazes, all these species are social species. I mean, I don't know whether cats can follow gazes, because cats don't care about others. But all these social species, it's important to see where somebody is looking at. There may be food where they are looking, there may be a danger. So knowing where others are looking, it's good social information. But it takes some capacity to understand spatial relations and so on. So this is a story about the baboon. Baboon troop, this was observed in the wild. And what happens here is that this is the alpha male of the troop, actually sitting further away. the picture here is drawn just so that he is in the picture. And this is one of the females in the group, and she is interested in this younger male. And being interested in the younger male means, among other things, that she wants to groom him. Now, if the alpha male saw that she was grooming the younger male, the alpha male would chase away the younger male. He wouldn't allow that. But now she happens to, or the younger male happens to be sitting behind a rock. I mean, this is the fun part of it. And she understands somehow that this alpha male cannot see what's going on behind the rock. And so she's looking, while she's grooming this younger male, she's looking all the time at where the alpha male is looking. And she somehow understands. So she has an imagination that this guy, she can understand that this guy cannot see what's behind the rock. And I hope you see that this is understanding that he's got another visual space than I have got. And that's fairly advanced. And this is, as a matter of fact, a case of deception. That is, I mean, she's using this situation in order to get a reward, that is being able to groom this younger male, that she wouldn't have got otherwise without this kind of deceptive behavior. Okay, that's a story, that's a field observation of deception. But that only requires understanding the attention of others. Getting to the desires of others, there is a nice experiment by some child psychologists. They sit with two groups of children, or one child at a time, but anyway. And they present two kinds of food, sweet crackers or broccoli. And all the children prefer the sweet crackers, of course. But the experiment shows that, sometimes shows that, for some children, shows that she likes the crackers, and sometimes she shows that she likes the broccoli. No language, just yummy, yummy signals and so on, showing that I really like the broccoli and so on. And then she asks the child, give me some food. And the 14-month-old children always gives her crackers because they think that she likes the crackers, because they like the crackers. While the 18-month-olds, they give her the thing that she has indicated that she likes. If she's indicated crackers, they give her crackers. If she's indicated broccoli, they give her broccoli. So the 18-month-old, they can understand that she doesn't have the same tastes, they have the same desires as they do. And there is a border here. We can do some experiment with primates. It's a bit difficult to do it with primates, but there are some experiments. And one of the first ones that was made was, you have two chimpanzees in a cage. And one of the chimpanzees can pull in, has a choice between pulling in two boards, actually. And on one board, there is one banana for the chimpanzee who's pulling, and one banana for the chimp in the other cage. The other chimp in the other cage can't do anything. And on the other board, there is one banana for the chimp that's pulling, and no banana for the other one. So if the chimp in the first case was caring about what the other gets, they would pull the one that gives two bananas. It turns out they pull randomly. They don't care about whether the other one gets a banana or not. And that seems a bit odd. I mean, why shouldn't they give the other? It's a member of the same flock and so on. Why shouldn't they give it? But they don't. The chimps don't care about whether the others get any banana or not. It turns out that if you do it with marmosets, that's a small monkey, they do this. And actually, this experiment, they had the reward. It might not have been a banana in this case, but anyway, they can pull in this board. They get nothing in either case. But in one case, the marmoset in the other cage gets a reward, and in one case, they don't get a reward. But these marmosets, they give a reward to the neighbor. So why? I mean, we think the marmosets, these small monkeys, are not as intelligent as the chimpanzees. Well, the difference is that, one difference that's been used as an explanation, that marmosets are collective breeders. They take care of their infants in the group. And that somehow has given them this incentive to help somebody else. That is not present in the chimpanzees. But these are, as you see, quite recent experiments. We don't know very much about whether other animals understand the desires of others. I mean, these are just two typical examples. takes some time to do these experiments, and we need to know much more about that. Similarly, with intentions. Here you can do an experiment where with children and with chimpanzees. And with chimpanzees, you have a chimp in a cage, and you reach out a banana, and when the chimp reaches out for the banana, you either pull it back, teasingly, or you pretend that you drop it. In either case, the chimp doesn't get a banana. And with the children, you reach out a toy, an interesting toy, and when the child reaches for the toy, you either pull it back or you pretend that you drop it. And then you look at the reactions. And it turns out that from 9 months and on, they react differently. That is, if you pull the banana back, the chimpanzee will become really mad. I mean, really crazy. He will beat about in the cage. But if you pretend, just seem to drop it, they will be disappointed, but they will not be mad with you. And the same thing with children. I mean, if you pull back the toy, they will be really disappointed. But if you pretend you drop it, they don't react in the same way. So they understand the difference between whether you're intentionally mean to them or whether you're just, there's an accident. But that's about all we know about understanding intention. There are no really good experiments here. And another thing that is very common in humans, I'll come back to that, is to have a joint intention. I mean, I may want to do something, and you may understand what I want to do. But having a joint intention means that we want to do the same thing. We have a common goal. And we understand the joint intention means that I want to do something, go to, let's take a very, very simple example. You're walking on the street together with a friend. You keep track of your friend. You don't lose him or her. You walk sometimes side by side or in front or back of each other, depending on whether there are many other people. But you somehow coordinate your movements. You do this automatically. You have this joint intention of going together to some place. You never see that in any other species. We haven't found any other examples of joint intentions that you adjust your behavior. Well, there are some discussions concerning cooperative hunting, but it's not interpreted as joint intention. We could discuss that afterwards if you like. I'll come back to this with joint intentions. Finally, we get into understanding the beliefs of others. And there is a classic experiment. You have two groups of children, 3-year-olds and 5-year-olds. And they're shown a tube with candies. I don't know if you know what Smarties tubes are. This is done in Britain. And you ask children what's in the tube, and they all say Smarties or sweets, something. You open the tube, and it turns out there are pencils in and they're all very, very surprised because they didn't expect that. And then you close the tube again, and you ask the child, now your friend is coming into the room. What do you think she will say about what's in the tube? And the 3-year-olds will say that, yeah, she would think there are pencils in the tube. And then if you have a 5-year-old, the 5-year-old will say, yeah, she will think there is candy in the tube, but we know that there are pencils, and they're very happy about this, sharing this knowledge with the experimenter. So the 5-year-olds, they can imagine that the other individual doesn't have the same knowledge as you have yourself. While a 3-year-old can't do that in general. It depends a little bit on the experimental setup, but this capacity of understanding that others don't have the same beliefs as you, it develops sometime between 3 and 4 years of age. You can do this experiment in a non-verbal way, without using language. And you can test it on chimps and apes or children. And children pass this non-verbal test when they're between 3 and 4, same age. No chimp has passed the test so far. So, so far, we are alone of passing these false belief tasks. I'm saying so far because some smart experimenter may set up an experiment where they show that the chimps can pass it, but so far. Okay, we can go further. Now I've talked about my understanding of your inner world, my understanding of your emotions, your attention, your desires, and so on, your beliefs. But we can go even further, and as humans we can think about I think about what you think about me. So when I'm talking here, I think that you understand what I want to say. And that already involves this kind of mirroring. And that's crucial for linguistic communication, that I have this, and I'm looking at you, I'm looking at your reactions, if you're smiling or if you think I'm stupid or whatever. And I adjust my behavior because I'm concerned about what you think about what I want to say to you. And we can do this nesting. I can think about what you think about what I think about, maybe what you, three or four and this is important when it comes to, I want to make a distinction between consciousness and self-consciousness. Consciousness means having perceptions, having feelings, seeing, listening, and feeling things, being aware of things, and so on. And that kind of consciousness, we can't prove it, but it's very likely that we find it in lots of animal species. Maybe not all species, but lots of species have perceptions and emotions and so on. There are all kinds of bodily reactions that shows this. There's no doubt that many animals can see and have this and even imagine things. But self-consciousness is reflecting upon your unconsciousness, thinking about what I'm feeling or thinking about what I want and so on. And for this future planning, we need self-consciousness. I have to think about how I will feel tomorrow. So that's necessary to have this capacity. And what I want to point out is that this capacity of understanding others goes very closely together with my capacity of understanding myself. Because if I can think about what you think about what I think about, then I can think about what I think about. And actually it develops, in this capacity, it develops between 3 and 4 years old of children as well. Okay, that was level of subcognition. I've talked about our capacity for planning. I've talked about our intersubjectivity, our theory of mind. Now we go to communication. And I've already hinted at this. There are two kinds of communication. What we can call signaling. That is, lots of animals signal the presence of food or danger or mates or call for their children and so on. You find a lot of communication in the animal world. Maybe one of the most fascinating ones are bees who communicate about where to find nectar. They fly out, they find nectar, they come back to the beehive and they dance to the other bees. And this dance indicates the distance and the angle to the place where the others. It's a fairly sophisticated system of communication among. The bees have a brain that is 1 cubic millimeter big. And they can still perform this dance. But all animal communication is about here and now. There is food here, there is danger there, there is a mate here, and so on. Also, that's signaling. It's signaling about here and now. But we as humans, we can talk with what I call symbols. You have tens of meanings of symbols, but the important thing about symbols is that they refer to things that are not here. I've been standing here for half an hour, or even more than that. Too long time already, I'm sorry. And I haven't said very much about this room or about what I see or what happens here. I talked about my inner world. I talk about things that are not present. And that's why we have language, in order to talk about what's not present. Okay, so why do we have this? Well, my explanation of why we have symbols, why no other animals have it, is that we need them to communicate about our future goals. If you are hunting, we are out in the wild, we want to hunt. It's enough that we can both see that we're hunting for the same thing. We don't have to communicate about something. But if we want to communicate about the future goal, that tomorrow we should go to this place, or tomorrow we should build this construction together, or tomorrow we should do this together, and so on. The goal is not present. We can't see the goal. We can't coordinate to something that is present in the environment. We have to coordinate our actions using some other means. So that's why we need the symbols. We can't cooperate about, we can plan for future goals without language, but we cannot cooperate for future goals without having a symbolic And my hypothesis is that the environment of the early hominids, it was an open savanna, and you needed to plan for future coordination. Much more than chimpanzees need to plan for their life in the woods. So the open savanna created some kind of selective pressure on communication about future goals. And that led to human language. So in linguists, sometimes make a distinction between proto-language, that is language that has a number of words where you can combine them, but where there is no syntax. And on the other hand, language, which has a grammar. You can combine them with certain rules. And maybe proto-language was sufficient for cooperation about future goals. You can make plans. Proto-language is Tarzan language. I mean, me, Tarzan, you, Jane, and so on. I mean, that's, you know what it is. And you can make some coordination with proto-language. Okay, so that's all I want to say at the moment about levels of communication. Let's go to levels of cooperation. And human cooperation involves a lot of things. Joint attention. I mean, here are these boys building a tower of blocks together. They're looking at the same thing, joint attention. They have a joint intention of building it. They may never have talked about building it, but it just emerges from there. And they have a joint belief of how things work here. We use this in our cooperation. We can distinguish between a lot of forms of cooperation. I mean, even when birds are flying in a flock, they are cooperating. They are flying in a flock because they can avoid birds of prey in that way. Or fish who are swimming in a flock, they avoid also predators. So that's a way of becoming safe. That doesn't take very much cognition. You only have to look at your closer friends. And basically, the simple rule is try to be in the middle of the flock, but don't collide with the others. I mean, that's the basic rules. And then you see flocking behavior. And in many species, you see in-group and out-group behavior. That is, you belong to a particular flock or something, and within the flock, you cooperate. But if you meet somebody else from another group, you are aggressive. And you see this in bees and ants. I mean, bees who meet a bee from another hive, they are aggressive. And they do this by smell. You don't smell nicely, so you. That's the simple rule. I mean, bees from the same hive, they smell the same thing. So we find that. And that doesn't take very much cognition either. You can do that by olfaction. Then, this is a more advanced thing. Reciprocal altruism is basically I scratch your back or you scratch mine. Here is a picture of two chimpanzees who are involved in reciprocal altruism. Well, you don't have to do it at the same time, but I help you in some situation, I expect you to help me back. That requires a little bit more. In game theory, this is modeled by iterated prisoner's dilemmas. I don't have time to talk about that, but it depends on also that if I help you, and you are not helping me when I need, I can hit you. I mean, I can retaliate. And when you establish this kind of cooperation, you build up some kind of trust. We can talk about the hormones involved in this and whatnot. What is needed here is quite a lot, actually. You have to remember rewards. I mean, I gave you a favor, and now you do me a favor back. And it should be basically of the same. So I have to plan for my future needs, in a sense. And it turns out that this remembering or thinking about future rewards has to be fairly constant over time. And we as humans are much better on this than rats and pigeons. I don't have time to get into the details of this picture. We have to keep track of interactions. I have to remember whether someone was nice to me or not. And we don't need very much of communication here. But you see, we have to have some form of memory, at least, to have this reciprocal altruism. Then I already talked about cooperation about future goals. And the important point here is that requires symbolic communication. Otherwise, we can't have the cooperation about future goals. I already talked about that. So that involves a fair amount of theory of mind and other things. And we don't find this in other species. There is a further form of cooperation that is even more advanced, and that's what's called indirect reciprocity. And it's best illustrated by the Good Samaritan. I help somebody, but I'm not expecting that this person is helping me back, because I only meet this guy once in my life. When you're out traveling and somebody on the road needs your help, well, sometimes you help them, sometimes not, but you're willing to give a sacrifice of your own without expecting to get something back. And from an evolutionary point of view, this is a bit strange, because there is a cost to you of helping somebody else, and you're not expecting to get anything back. So if you take Darwin's idea about the survival of the fittest and so on, this seems like a thing that shouldn't exist in biological terms. Okay, we can talk about the human goodness or whatnot, but if you're a true biologist, true Darwinist, this is not sufficient. Some people have tried to model this, and there is a paper by Novak and Sigmund who have made a game theoretical model of this process. And their idea is I'll skip a bit here because I'm short of time here. The question is, when can such behavior evolve? And one problem is that if I have reciprocal altruism, I mean, I'm helping you, I'm expecting you to help me back, I can retaliate. But if I'm helping somebody on the street, I'm not expecting the person. If the other person doesn't help me back, I can't retaliate because he or she is gone since long. So how can we solve it? Well, their solution is that we have a mechanism of reputation. That is, I help you, and somebody is looking at me helping you, and then this information is spread in the group. The word gossip is written here. And so I get a better status by helping somebody else. And then by having this status, when somebody else meets me, if they know I'm a good guy, they will help me. If they know I'm a bad guy, they will avoid me in cooperation. So by including this reputation mechanism, you get an explanation of how you can establish helping others as a biological valid mechanism. But what Novak and Sigmund don't write about in this article is what kind of communication you need. Basically, you need gossip. You need to talk about other people who are not present. You saw somebody being nasty to somebody else, and you tell to your friend or your child that avoid this person because they are not nice. Don't do it, even when they're not present. This is reputation. This is what gossip is about. I mean, spreading the reputation of other people. So, now if we look at the cognitive demands, first of all, you have to recognize individuals. Remember who is nice and who is not. You have to do that in reciprocal altruism as well. You have to remember a reputation score. So, I mean, this is basically who is good and who is bad, but you can have degrees here. And you have to judge actions, whether they're good and bad. That's maybe not so difficult either. But if you look at the communication, we need quite a lot. We need to refer to individuals in their absence. And we can do that by description, but we normally do it by name. So we can do it. You know this guy with the funny nose. I mean, he was very nasty last night and so on. But there is no animal communication system that has anything like names to refer to individuals in their absence. We have it, and we need it for this kind of reputation scoring. We need to distinguish between X was good to Y or Y was bad to X. We need to distinguish whether it was X that was good to Y or whether it was Y that was good to X. And if you're a linguist, you will notice that this is marking of roles. You have to mark which is the good guy and the actor and the benefactor, the subject and the object, if you like, in a phrase. So this is a minimal form of syntax, to mark roles. And I mean, basically, this is what subject and object is about. I mean, to mark who's doing and who's being the subject, the object of the action. So the reputation mechanism requires a minimal form of syntax. I'm not saying it needs tenses or anything like that or pronouns, but it needs at least role marking. So this form of cooperation is dependent on a more advanced form of symbolic communication. So, I will finish here by two theses concerning the evolution of language. Proto-language is efficient system, maybe, probably sufficient for cooperation about future goals. And language with syntax, some form of syntax, is sufficient for maintaining indirect reciprocity, this kind of reputation mechanism. If you look around in the world, we are very much dependent on this reputation for building up human societies. Human groups are so big that we can't observe everybody at the same time. We are much greater flocks than there are chimps. Chimps are normally in size of a group of 30 to 50. Robin Dunbar estimates that human groups are evolutionarily on the size 150 to 200. You can remember that many people, but if you want to talk about your neighbors, I mean neighboring groups, then you need some other mechanism. You need reputation. Okay, so I'll skip this table because it's too complicated, and I'll just summarize here. So, the ecology of the early humans, living on an open area where you had to travel at longer distances, where you have to plan in order to get your food, made advanced forms of cooperation evolutionarily beneficial. I mean, cooperating about future goals will help you in the savannah life. And I've talked about this co-evolution of cooperation, cognition, and cognition I divided into prospective planning and intersubjectivity. And that brings out a need for communication about what's not present. And that's why we are the only species who has a symbolic language. And then you can discuss how much symbolic language we need to solve the different forms of cooperation. I have my distinction between proto-language and full language with syntax here. But that's a minor detail of it all. So I've given you a €6 million long story in a little bit more than an hour. Thank you very much.
Hi, Professor. First of all, thank you for a brilliant, amazing talk. It's actually, first of all, I was wondering about the question of reputation. Do you think that the hypothesis of the selfish gene could help us understand the question of the reputation? I mean that it could be a mimetic hypothesis, that it could be evolutionary written in genes, so it would replicate genetically in generations. And then I have, I guess, two less technical questions. The first one is more specifically about monkeys. Considering what we know about monkeys, I mean, even the experiments you've given us, and the amount of preferences that they are able to have, I mean, should we be just assuming they're okay with being experimented upon? And moreover, shouldn't we extend human rights to monkeys? With what we know, I think there is a case to be made about that. And just to point it out, I've been reading a lot about the question of cooperation and the fairness hypothesis. And I don't know if there's been new developments, but that one of the most important elements in making the distinction between the kind of monkeys that we are and the kind of monkeys that the great apes are, is that great apes are not immediately able to recognize fairness unless they are domesticated. Yep. That domesticated apes are able to have something like a conception of fairness, but not apes in the wild. And it seems that if we follow even Geertz and Geertz's hypothesis of the development of the subcortex with culture, that could be an interesting way of approaching how our way of understanding ourselves is developing. So I just wanted to know what you make of this hypothesis.
Okay. That's three big questions. Okay, the first one about the mimetic thing. I mean, what I think is genetically given is this capacity for intersubjectivity. I mean, we have all of us develop, I mean, more or less automatically, I shouldn't say all of us, most of us develop more or less automatically these capacities for understanding the emotions of others, the attention of others, and so on. And I mean, this is one piece of evidence is that this capacity to understand beliefs of others comes between 3 and 4 years old. I mean, there's not very much variation. There are a few exceptions, and that is children with autism. They have problems for joint attention, and they have sometimes problems with understanding beliefs of others. So children in this with these kind of problems, they have less intersubjectivity than people with typical development. So I'm not saying that the reputation thing in itself is genetically given, but the intersubjectivity is. And on top of that, we build a lot of culture. I mean, you can't get reputation going without language, which I think is a cultural mechanism and so on. So that's all I have to say about your first question. Then the question about the morality of keeping monkeys in cages. I mean, it's a big question. I have no particular opinion. I mean, I have a concern. I prefer the animal studies in the wild, when you go out and observe things in ordinary environments of the animals. But if you want to have controlled experiments, it's very difficult to do it unless you have them in cages. I mean, I know there are lots of moral dilemmas here. And I have no particular solution to these dilemmas. I mean, it depends on how, I mean, we are giving the animals more and more value, so to speak. We have changed the ethical rules for animal experiments. We've even changed them to the extent that we have stricter rules on animal experiments than we have on human experiments in many cases. So, in particular when it comes to medical things. So there is a development here, but I have no particular things to say about that. Then your third question about what we know about monkeys and fairness. I mean, fairness is a very interesting problem. I was talking about this, whether they could give something to somebody else. You're referring to these experiments on what is it called? Yeah, no, but it's the game, the ultimatum game. Yeah, the ultimatum game is that you give one animal 10 pieces of fruit, and the animal can give the other animal as many as they want, and then. No, I'm sorry. The first animal is given 10, and the first animal can decide how many to give to the other animal. If you do this, and then the other animal can decide whether it accepts this offer or not. So if it only gets one, it can say no, refuse, and then nobody gets anything. So it's an ultimatum. The first one gives the other one an ultimatum, and then the other ones can either accept or refuse. If you do this with humans, offer them $10 and divide it, or $100 to divide it, people in general refuse unless they get about 30% from the dictator. They refuse. If you do this with monkeys or with apes, they've done it with apes, they never refuse. They accept anything. Even if they get nothing, they give the 10 to the other one. So they don't have, I mean, this is evidence that they don't have this sense of fairness. This is a new experimental area. I don't know what would happen if you did it with the marmosets who have I don't know if it's been tried on monkeys here. But I mean, this is, of course, a very interesting concept, and also a concept from our moral evaluation of these animals. That's not an answer, but I'm just acknowledging that it's a very good question to study their sense of fairness.
So I have two questions. The first one is about the reciprocity and gossip stuff. So if I understood you well, you're arguing that the fact that we perform altruistic acts leads to acts of communication among people living in the community that I live, and my goal when I perform an altruistic act is to build a reputation, right? So my first question is about the evidence that gives support to that claim, and there's also cases. Well, some of us have experienced. In some cases, some of us. We feel sometimes the urge to perform altruistic acts, even though we know that nobody is looking at us, and we know that we will not get any third-person reward for our altruistic act, and even though we perform this altruistic acts. For example, my girlfriend is sleeping, and I know that she likes me scratching her back, and I know that she will not remember, for example, and I scratch her back. So this is the first question about the evidence in support of your claim and in these cases. The other one is, how does your schema, your tripartite schema, so to say, about the evolution bears on abstract thinking and doing science? Because how can we explain the origin of abstract thought, logical and mathematical thought in that scheme?
Yeah. Okay. Two more big questions. The first, I have to clarify your description of my analysis of indirect reciprocity here. What I'm saying is that indirect reciprocity requires symbolic communication in order to get started. So we must have that at the beginning, first of all. Otherwise, we can't build up this mechanism of reputation. So that's somehow required in order to get started. And the point is that by looking at this game theoretical structure, what you gain, what you lose, and so on, you can show that there are selection pressures will generate favors for those who are good at keeping track of their reputation in others and using that in their own interaction with other individuals. Then, this happens quite often in evolution. This mechanism is then strengthened by evolving emotional systems. The emotional system is adapting to these strategies. So you feel good when we do this. I mean, this is on top of it. It's strengthening the selection mechanism. We have in many. I didn't talk about shame and guilt, but we have these feelings in many social animals. I mean, dogs can be ashamed. I have never seen a cat that is ashamed. I mean, this is my interpretation. And the reason is that dogs are social animals, cats are not. So the dogs need this kind of shame mechanism in order to, well, they show that they're ashamed when they've done something bad, I mean, stolen food from somebody else, in order that the leader of the group doesn't punish them. That's the mechanism of shame. So evolution often works with adding emotions as a strengthening of the behavioral mechanism. I mean, I'm not an expert on emotions, but I know that. So that would be my explanation. That means that very often you can do altruistic acts just because it feels good, without caring about your own reputation and so on. It's a side effect of this mechanism. Now I lost your second question. I'm sorry. It was abstract thinking. Yes. Okay, let me tell you a story. I had a second PhD student, Thomas Persson, who was studying the ability to understand pictures. He started with gorillas, but in the apes. And there are three levels of understanding pictures. One is just to see that something is visual patterns, and that all animals can do. The second level is to understand that it shows something, that it's a picture of a banana. And that many animals can do. And as a matter of fact, if you show a chimpanzee a picture of a banana, they will very often try to eat the picture because they think. And the same thing is with small children. If you show a child a picture of a candy, they will try to eat the picture. I mean, if they are fairly small, they will do that. But the third level of understanding of pictures is to understand that it's a representation of something. And Thomas Persson wanted to do a very simple thing. He put rewards in one of two boxes. I mean, he put a piece of fruit in one box and nothing in the other box. And then he put the picture of the reward on top of the box. And he wanted the gorillas to select the box. There was one good thing, a fruit, and then it was cucumber in the other. And they eat cucumber, but they don't like it that much. So they should choose the box where it had the right picture was. And he tried this experiment 1,000 times on each gorilla, and they failed. They still choose randomly. They couldn't understand that this picture was a representation of what was in the box. So he tried this, and it was a big surprise. I mean, that was his PhD project, and we almost gave up on it. Then he went to the United States to meet some of the chimps that have been language trained. They know how to communicate with symbols. They managed this with flying colors. They immediately solved the problem. They could do it even if it was just black and white pictures of fruits and so on. And they've never been trained on this picture understanding. But the very fact that they have learned this kind of symbolic connection between the signs and the representation gave them the capacity to understand pictures at the same time. So this long story is, the answer to you is that I think that language is a very important element in developing our abstract thinking. Language is, words are about patterns in the world. I mean, we use the word chair to represent what chair is a modern word. Take tree. I mean, trees can look very differently, but we still learn to categorize things as tree in difference to bushes and so on by some kind of visual pattern. I mean, the tree has a trunk and so on. And the word helps us to see a very abstract structure that we can then use in all kinds of reasoning. So my short answer is that language gives us this capacity for abstract reasoning.
You have talked about that language is a result of evolution of coordination of action, collaboration and coordination. But many species collaborate to hunt, like wolves, and they never develop written and external symbols for the language. And also the first register of external symbol for human is recording, is not planning for the futures, like we found in caves, description of hunting and so on. It seems to me that the origin of the language is more related with trial to tell a story than trial to make a plan.
Thank you. The first part is the collaborative hunting that you find in lions and wolves, and even in chimpanzees do collaborative hunting. They hunt monkeys in the forest. You see a lot of collaboration there. You see fairly advanced collaboration. But there is they don't sit down at the beginning and make up a plan of how to surround something. They look at the behavior of others, and they adapt their behavior to the behavior of the other animals. Well, actually, one of the most beautiful examples of cooperative hunting are a group of dolphins who are surrounding a school of fish. They swim around it, and they keep the school of fish inside. And then they take turns in going in and eating from the fish. So they have this joint goal of surrounding this school of fish. No. I don't know if they have a leader, but this, wolves have leaders. But there is planning during the hunt, so to speak. And they can coordinate very well, and they can be very smart coordination. I mean, I gave you this example of dolphins. But that doesn't mean they're planning for your future goal at all. I mean, smart coordination, and you can take all different roles, actually. In chimpanzee hunting, they take different roles. Your second question, I think you mentioned the first external form of symbolic, and that's in the cave things. Then we come very far, because now we are putting language outside of us. And that's very late in human evolution. But I still think you have a point in the importance of telling a story. Because this reputation depends on telling stories about what other people did, who did what to whom. I mean, that's So gossip is about telling stories. So planning for future cooperation, that's coordinating for future cooperation, that's planning, that's talking about the future. But the gossip mechanism is actually telling stories. So stories are important in human language.
Okay, it's a very short one. Could you
maybe could we connect the emotion of satisfaction and deception into this development of language? If I feel satisfied, maybe then I want to tell the others, or maybe I want to share in this cooperation. I feel something good, and then I start to. This would be maybe an idea of these feelings of satisfaction in deception, and then taking care of the others or sharing with the others good sensations, good emotion, good sensations that would transform in good emotions, and then the idea of being a social, part of social.
Yes, I think so. I mean, we can't go back in time and look at what's happening in a few 100,000 years ago, but we can go back to what is the most similar situation. That is the hunter-gatherers that exist now. We can see what they are talking about. I don't want to say that they are working in the same thing as humans did 200,000 years ago, but still, if you see what people talk about, they tell lots about stories, about hunting, about collecting food, about accidents, and so on. Most of the time, we are all humans. We tell about our successes. When it was a good. Facebook is. Thank you. Facebook is a good example of what we want to present ourselves in a good way, and that's because if we succeed in doing that, this is a form of deception. I mean, we all tell more or less true stories about our lives, and that we want to do that because if we convince the others we are good hunters, our reputation will go up and people want to cooperate with us. But sometimes they also tell stories about failures, but then people laugh. I mean, it's a kind of relief feeling when they talk about failures. And the worst stories are about when somebody has been fooled and is angry because somebody has fooled them. And then it's very important to tell the rest of your tribe or group that don't trust this guy. Never cooperate with him or her. I mean, that's So there are different emotions involved in different ways of building up this reputation mechanism. Okay. All right. Thank you.